Greetings Year 11/12 students. Let's talk about exercise 3E where we're going to use graphs to solve equations and inequations. So the first example, I've actually got a grid here to make it a little bit easier, and we're being asked to graph a parabola and a hyperbola. Now y equals x squared is a parabola that opens upwards, y equals minus x squared opens downwards, y equals minus x squared plus 4, which is what this is, just written in reverse, is a parabola that opens upwards and goes through at 4. So I know it goes through 1, 2, 3 at 4, and the x-intercepts will be at 2 and 2, because 2 squared is 4. When I plug in x equals 1, 1 squared is 1, 4 take 1 is 3, so it's 1, 3. Symmetrically, it'll be 1, minus 1, 3. So my parabola goes something like oops, got a bit dodgy there. Let's tidy that up a bit. Something like that. That's close enough. That's my rough sketch. Now, y equals 1 on x. I'll graph that in a different colour. Now, y equals 1 on x. Let's just make sure we get this right. We know it's a hyperbola. So, if I was actually going to plot some points, I just want a couple of them. So, let's plot when x is minus 2, minus 1, 1 and 2. That'll do. When x is minus 2, it's minus a half, minus 1, 1 and a half. So when I plot this, I go minus 2 down a half, minus 2 down a half, not minus 1, minus 1, minus 1. If I went, I'll put an extra point in, probably be a good idea, minus 3 and 3, be minus a third and plus a third. So minus 3 a third, about there. Go like this. And when I will go to 1, 1, I go to 2, a half, 3, a third. If I go to a half, when x is a half, 1 over a half is equal to 2. So go to a half, I'm up at 2. If I go to a quarter, 1 over a quarter is up at 4. So a quarter up at 4. So it's going to go through like this. And there's my sketch. Now it says, use a graph from part A to investigate where y equals 4 take x squared and y equals 1 take x are equal. Well, I can see where they're equal. They're equal there, there, and there at the points of intersection. So here are my points of intersection. 1, 2, and 3. So how many solutions does the equation have? And approximately what are they? There are 3 solutions. And they are x equals approximately, now what's the x value of this point here? It's a little bit to the left of minus 2. I might say approximately minus 2.1. I don't know, I'm guessing. This is only approximations. This point here, maybe it's about, I know at a quarter I went up 4, that's a bit higher, so it's a little bit bigger than a quarter. Quarter's 0.25, so it might be 0.26, 0.27. I'm guessing. It's an approximation. And the last one, this one here, a little bit less than 2, so I might say it's 1.9. I don't know, close enough. They're just approximations. So that's approximately what they are. Let's go to the next part. First one says graph y equals 2x take 5 with absolute value signs around it. Okay, so let's see what that would look like. So the absolute value of 2x take 5. 2x take 5 equals 0, 2x equals 5, 5 over 2, so that's 2.5. So I'm going to go 1, 2, 3, 4, 5. Oops. Didn't really space those very well. 4, 5, that's probably still not flash, but that'll do. So there's 2.5. And when x is 0, y is going to be 5. Let's make that 5 up there. So this is a straight line, it's a V graph. And that there is at 5, 5, and that's at 0, 5 there. So there's my victory graph, my V graph. Now, it says to write down the equations for the right hand and the left hand branches. So the right hand branch is this branch here. Now that's really the same as, so for the right hand branch, the right hand branch is the same as the line y equals 2x take 5. We don't actually worry about this part of the line, so we're only graphing y equals 2x take 5, and we're graphing it for x's to the right and including 2.5. For the left-hand branch, that's this one here, in green, well, that's the line y equals minus 2x plus 5. And that's for x values to the left of 2.5. So there's my left branch and my right branch equations. One's the positive case, one's the negative case, but we only want it to the left and right of 2.5. Part C says on the same diagram, draw the graph of y equals x plus 2. Well, y equals x plus 2. Now let's think about y equals x plus 2. When x is 0, y is 2. So y is 2 would be somewhere like this here. And when x is, let's say, when x is 1, y is 3, slight angle, and it's going to go something like this. It's not really drawn to scale. And there's my y equals x plus 2. So there's 2, there's 2, 3, going like 1, 3, and so on. Now, hence find the points P and Q of intersection. So this point here I'll call, oops, not that one, intersection I want. This point here I'll call P, and this point here I'll call Q. Now, how do you find the points of intersection? Well, what we're interested in is where does this line, let's find P. P is where does this line here hit the green curve. So, to find where the point P is, we're going to sub y equals x plus 2 into y equals minus 2x plus 5, which will give me x plus 2 equals minus 2x plus 5, which gives me 3x equals 3 and x equals 1 if I follow that through. And if I plug x equals 1 back into this one here, that will give me y equals 3. So P is 1, 3. Let's find Q. For Q, I want to plug, I've got the purple line and the yellow line, that's where they meet. So I'm going to substitute the yellow line, or the orangey coloured line. So y equals x plus 2 into my orangey coloured line, which was sorry, into my purple line, which is y equals 2x take 5. So I get x plus 2 equals 2x take 5. Rearrange that, and I get x equals 7. And if x equals 7, plugging that back into here, 7 plus 2 is 9, y equals 9. So the point Q is the point 7, 9. So I found P and Q. Part E says solve absolute value equals x plus 2. Well, this is an absolute value graph, so I'm going to have to solve it for the plus case and for the minus case. Here's the plus case. 2x take 5 equals x plus 2, minus x to both sides and plus 5 to both sides, and I get x equals 7. For the minus case, minus 2x plus 5 equals x plus 2, plus 2x to both sides, minus 2 to both sides, and I get x equals 1. Now that actually makes sense. X is 1, x is 7. Look at the x values of the points P and Q, 1 and 7. So that actually validates that as well. Now, part F says solve where the absolute value of 2x take 5 is bigger than or equal to x plus 2. If I look at the graph, it's saying where is your absolute value graph above the line y equals x plus 2. Well, if I look at the graph, I can see where it's above. It's above in these positions here. The exponential graph has to be above my goal graph. So it's above it here and here. So if I look at this point here, that has an x value of 1, so it's above it to the left of 1. And where else? To the right of, now what's point Q? 7, 9, and to the right of 7. Now, it didn't just say above, it said above or touching. So it's there and there. And there is your solution. So now it is time for you to try some. Enjoy the experience and have a great deal of fun. Bye for now.